Hello everyone. So today I'm going to prepare P3HT organic semiconductor with PVDF, as you can see here, PVDF-HFP materials. So I will be using THF, tetrahydrofuran, as the solvent for both P3HT and for this. So my target will be like to mix them together. So I will be first preparing the P3HT with the tetrahydrofuran, and we will put it in a vial. So I am considering to make it for 10 milligram per milliliter concentration. Then I will prepare the PVDF-HFP with the tetrahydrofuran solution. This time I will make the solution to be like 100 milligram per milliliter. After that, what I will do is I will add both of these together, so that in the final solution I will have 5 milligram per milliliter concentration of P3HT and 50 milligram per milliliter concentration of PVDF-HFP. So what I will do is I will take 1 milliliter from here and 1 milliliter from here, and then we'll mix them together. So this will be our final semiconductor for organic semiconductor material based device. So let's start it with the mix first with the P3HT solution preparation. So what I will do is, like, I have this weight scale. So as you can see, the primary requirement is that you should make sure that the bubble here is in the middle. So you can just you need to make sure the bubble is in the middle. To make sure that you can, like, there is some knobs here and there, so you can just change the knobs, and that will change the position of the bubble. Make sure the bubble is in the middle, so that it will be like your weight scale is properly balanced. Since we are considering very small amount, we need to make sure that our weight scale is properly balanced. So as you can see, it's properly balanced now. Now what I will do is, like, I need 10 milligram per milliliter solution. So I will measure some P3HT and in milligram, and we'll divide that with 10 by the concentration, which is 10 milligram per milliliter. That will give me the amount of volume I need for the solution. So the volume that I will be getting by dividing the measured weight by the considered concentration of 10 milligram per milliliter, I will use the volume with here. As you can see, like here in this THF solution, there is like density 0.889 gram per milliliter. So this is like the density of the solvent. So what I will do, the volume that I will get by dividing the weight of P3HT with the concentration, I will multiply that volume with this density. This will give me the amount of gram of solvent I required for making this solution. So what I am doing here is, I am first calculating the volume I required for the solvent, and then converting the volume to the gram, since I will be measuring it in the gram. So let's get started with that. So here I have this spatula. So what I did is, I first washed it with acetone and then washed it with IPA. So make sure you put it in the vertical direction while washing, so that the liquid goes straight down through the cavity. Yeah.
I'm talking about this one. This is not vacuum. Oh, yeah. What is it? Yeah, they're curing at 70 degrees Celsius. Yeah, but he has been curing it since, I think this one is since Friday. Okay, thank you.
So as you can see, we have prepared like 0.120 or 12 milligram of P3HT. Now what I will do is I will divide this 12 with my desired concentration of 10. That will give me 1.2. So this is 1.2 milliliter volume I need for the solvent. I need to convert this 1.2 to the required gram of the solvent. So I need to multiply 0.889 gram with 1.2. Let's see what that gives us. So I have calculated that the required gram value of this of the solvent is if we divide the required volume of the measured weight of 12 milligram divided by 10, that is our concentration, we will get around 1.2 milliliter of volume, and if we multiply that volume with the density of here of this solvent, then we will get around like 1.07 gram of THF. So I will measure 1.07 gram and add it to that. For this I need syringe. So I have the syringe and the thing here, so let's get started with it. What I'll do is I need to pull it down. You should remember that if after measuring something you can put like tear, and that will like make everything that is right now to be default 0, and everything that you will add after that will be showing here. So I need the required gram is 1.07. So let's add that to here. So that's it for our THF solution. Just make sure that you properly seal it to this sharp. Okay, now what I need to do is I like to close it up and seal it down and warm it. So let's put some so I've taken some paraffin, so as you can see. close it tightly because the heat will likely to make it moving. I also need some scotch tape. That's it. Just note it down, okay? So PDMS. So much PDMS. Let's add some tag here. So we need to warm it up till all these particles they are dissolved properly. We need to make sure they are clean. So yes, I'm giving it 80 degrees centigrade temperature, and let's put a timer here. Let's make it for 10 minutes. I think 10 to 15 minutes will be enough. So let's put a timer and 15 minutes. Let's make it warm up. Okay, now let's measure THF solution. So we are now measuring the second solution that we have here. We'll be preparing PVDF-HFP, this solution with similarly THF solvent. So this time we'll be preparing for 100 milligram per milliliter. This is because we'll be then mixing together. So let's first tear it up so everything is zero. We need to put the vials here. So this is the process you will try to follow everywhere. So my vial is 10 milligram, but I don't want to measure it. So what we can do is click tear, and it will automatically make it to zero. So everything that is added to this part now will be showing here. So first of all, what I will do is I will measure the weight of this PVDF-HFP solids and solid parts, and then we'll divide it by 100 milligram per milliliter so that we can get the required volume of the solvent. And after getting that volume, we'll multiply it with this density here to measure the required gram of the solvent. So what we are doing here is similarly we are first using the required concentration, we are calculating the required volume of the solvent in milliliter, and after that we will be converting the milliliter into grams so that we can measure it through this weight scale. So let's start with with the solids here. So we have the vials. So as you can see here, I have weighted like around 0.205 gram. So that means like around 204 milligram of this solvent. So what I'll be needing now is, what I'll do is now I'll divide this by the required concentration, that is 100 milligram per milliliter, and after that I will have around like you see around 2.05 gram, 2.05 milliliter, sorry, 2.05 milliliter. And then what I will do is like I will multiply that 2.05 with 0.889 to have the required gram of this solvent. So let's multiply. So after multiplying, it will give us around 1.82 gram of 1.82 gram of THF. So let's measure 1.82 gram of THF and mix it with our solvent. Similarly, what we will do, we will use a syringe and consider this. Let's stir it. I need 1.82 gram of THF. So let's add it. So that is it. We have measured our required solvent. Now what I'll do is now first of all you need to make sure you put it clearly. So let's close it up. And then let's put it out here. So this solution, these hard particles, what happens is like these particles, they do not dissolve easily. So what I will need is, I need a magnetic stir and stir it in the magnetic hot plate while heating. So let's go and find a magnetic stir particle. So here are the magnetic particles. Let's take two from here. These are not clean, so I need to clean it. Let's go. Let's clean it with acetone and IPA. So I have cleaned it. I have cleaned these magnetic particles. So what I'll do is I'll put them to this so that I can rotate it up. Also I need notation. So let's put it here. No.
I think so.
So what I'll do is I'll just close it up, and I need another thing.
I have to go now and now, so. Alright.
So, okay, we are done. It's almost sealed up, but I will need just let's close everything and put everything where it belongs. And also you need to make sure that after every time you do experimental work, you should clean it up, clean the environment whole, so that next user will not feel like bad or will have to do the dirty work first before doing the experiments. So now we have put the magnetic stirrer here. So what we'll need is to heat it while also make it rotate. So what we'll do is we need another hot plate. Let's also put it here at 80 degrees centigrade, and we will take around 400 rpm to make the solids dissolve quickly. So let's, here it is 20, it's 40, here it is around 83. I know it's kind of look weird, but this is how it is. So 95, 96. So that is around 85, and make the RPMs to 400. See, the rotation already started. We need to rotate it. Around 400 would be enough, so it doesn't need to be precise. So I'll just put it here. Also our timer here is done, and as you can see, the particles, it's almost dissolved, right? It's almost dissolved. So let me just put it in clear. Here, almost dissolved, but still there are some particles. So we'll put it another 5 minutes. Let's put it for another 5 minutes. I need to use my both hands, so give me a sec. Okay, let's make it 5 more minutes, and we'll be done with our P3HT solution to be dissolving. Okay, and regarding this, we need another timer. So we also need to make sure that it is also stays around 10 or 15 minutes in the hot plate while it is in performing magnetic rotations. So here is like another timer. So let's make it like around say I think 15 minutes should be enough. Let's make it 20 to make sure everything is. So here it goes. Another 20 minutes. Let's let it to be done. Meanwhile, what we'll do is we'll prepare some electrodes so that we can measure it, the solution properly. But I think before measuring the electrode, we need to make sure to prepare some PDMS. So we are here to measure some PDMS solution, to prepare some PDMS solution. So what I'll do is I need to so I have taken like sample vials and I'll like put it here. So our concentration should be I will be using PDMS solution with silicone elastomer curing agent. The ratio should be 10:1. So for every 10 percentage of PDMS, I will be using 1% of elastomer curing agent. What I will be needing is I need be needing a tool like this one and also a pipette. So let's take a new pipette. So here we go. We have our both requirements. So first I'll be using like one glass slide. So I will be needing like 5 to 10 gram. That should be enough. So first like put the PDMS here. So I have measured around like 6.23 gram of PDMS. So in that case I will need like 0.63 gram of elastomer curing agent. So let's add that. This is our elastomer curing agent and this was the PDMS, as you can see. So let's use 0.63 gram of curing agent. You need to be precise here because the curing agent could change the property of PDMS. So we are done here. Let's close it up. Now what I'll be needing is I need to use this tool and properly like stir it properly so there is no adhesive, something like that. Just make it sure you have measured it properly, right? Now in that case, like if you like want or if you are looking for, so our P3HT is done. So just stir it. Okay. So our P3HT is done. So let's see what it is like. So it is almost clear. It's almost like clear, most likely clear. Yeah, let me just show you all. So As you can see, it's very clear. There is no like solid parts here. So what I'll do is now I will try to make some structure engineering here for this. So how to do this is like you need to put this P3HT solution into the freezer, not the like refrigerator. It's the freezer where we use to make ice, and let's put it here for like around say 20 minutes to I think 15 minutes will be enough. So 15 to 30 or 20, whatever you like it. So this is our solution. Let's put it here for like 20 minutes. So I am adding the 20 minutes here so that I remember that I will be putting it out from after 20 minutes. So there it is.